Right, so now I want to look at the second stage of the exploratory data analysis, which is about data visualization. So in this case, we want to start with data visualization so there's going to be 2.2.1. Yep. So data visualization, right? Data visualization for quantitative variables, right? Then in our um, next case, we'll be looking at data visualization for the categorical variable, right? So let's run this. Okay, so we want to start with histogram plot. So I'm going to create histogram plot, right? And we know histogram is basically a way to graphically represent the distribution of your data using bars of different heights, right? So let's start with the most commonly used graphs for quantitative variables, which we are going to start with histogram. So how do we create a histogram plot? First of all, we have to install a library known as the matplot library, which has some advanced features which can improve the quality and aesthetics of the graphics, right? So I'm gonna install and load the matplot library, library. Yep. So how do we install? Use the pip function, pip install matplot lib. Right, so because I've already installed this, I'm not going to run this line. I'm going to skip and just import matplotlib, right? But we are interested in a particular function, this library, which is pyplot. So I can skip this and just say from matplotlib import pyplot as plt. Short form of pyplot is plt. So let's run this. Shift enter. So if you have not installed the library for the first time, then you have to use these three lines, right? You can just run all this. But if you have already installed the matplotlib, then you can skip this and skip that. Okay. All right. So we can start with histogram plot. So I can give a name to the histogram like HST to be the name. So I'm going to say hist, right? And it's coming from pyplot. So let me call the name pyplot plt.hist and my x variable. Alright, I want to, for my final dot, I want to get a histogram plot of sepal.length or sepal length. So I'm going to say sepal.length. Alright, then I want to get a count, not the probability density on the y-axis. So I'm going to say density should be false, right? Then I can give bins, right, to dictate this by default. The bins basically represent a range of values, right? And it's the height of the bars will basically represent how many data points fall in that range. So let's plot this, let's run this. So let's see. Okay, so here we go. So you can see our histogram plot. Maybe we can add more features to this. Let's say from pyplot plt, we want to rename the x coordinate. We want to say this should be sepal.length, right? And on my y coordinate, copy this, paste, and say this should be frequency. That's going to be the y lib frequency. Yeah. So let me change this to y lib. So So, and let me give a title. So this should be title, biplot title. So histogram plot of sepal length. Right. Let me remove the dot sign. Okay, so let's run this, shift enter. So we have given a label on the y-axis. On the x-axis we have sepal length. Right, we have let me close this. So we have sepal length on the y-axis. We have frequency, and you also have the title histogram plot of sepal length. Right, so this is just for one, but we have 4 features or variables. So how do we do that? How do we get all the histogram plot of this all 4 features or variables? So I'm going to say final that I want to extract all these variables. So let me give the name sepal.length. The second one is petal dot no sepal dot width. Then I can also get that of petal dot length and that of petal dot width. Right. Then from here we can get our histogram plot and say now I want the density. Density should be true. Now I want to see the probabilities on the y-axis, so I can change this to true, and basically bins should be 30 by default. Okay, this should be good to go. So let me scroll back. Okay, so let's run this, shift enter. Okay, so here we go. Right, this seems to be very small. Let me try and add one more argument and say fixed size should be have a width of 10, height of let's say 8. Shift enter. So this should be a little bit clearer. Let's wait. It's still compiling. Right. Okay, so this looks a little bit okay. So we have the histogram plot for all the 4 variables. Right, so we have this. Basically, the software can give you the result, but as a statistician, you should be able to interpret this output for the non-statistician to be able to understand these graphics that you have. Okay, so now that we are done with this, what can we do again? We can also get a histogram plot of the sepal length across the levels of the species, right? So let's say I want to get a histogram plot of the sepal length across the levels of the species, right? So how do we do that? We can say for my final that, right, that's basically what we are trying to use, our clean data. We want to say let's say group, should it be group? We want to, okay, so this should be because we want to get a histogram plot of the sepal length across the levels of the species. Let's use pivot instead. Yep, pivots, columns. Then column should be we want the species, right? Then the values should be the sepal length, right? Sepal dot length. Then we can from here we can plot our histogram, and let's say bins should be 30 as usual. You can also add density to it if you want, true, right? And let's see what we're going to get. So the pivot function is basically going to help us to get the levels of the species, right, for the sepal length. So let's say this, shift enter. Alright, so here we go. So you can see that, right, this looks nice. Right, so we can see the setosa in the sepal length, which has been colored blue. The orange seems to be that of versicolor. You can see it, and you can see that of virginica, right, in green. So what can we do again? Let's say alternatively, we can also use another library. So we can also use the Seaborn library to basically get our plots. So let's say alternative way of getting histogram plot. Right, so I want to make use of the Seaborn library. If you have not installed, you have to install by making use of the pip function. Pip install Seaborn. Right, so it's alternative of getting histogram plot using Seaborn library. Right, so this is how you install. If you have already installed, you can skip this and just import Seaborn as SNS, right? This is just an abbreviation for Seaborn. You can change it if you wish. Right, so let's try and import this. Okay, let's run this. Okay, so once we are done with this, we can say, let me give a name, histogram, right? H1, and say from Seaborn, so SNS. I want to get a histogram plot, right? Hist plot, and this time my x coordinate, I want to plot that of sepal dot length, and my data is coming from fdat. That's the final data or the clean data. So I think we are good to go. Okay, so let's try and run this. Shift enter. So here we go. Right, and we can also try and get a density plot across, so that we want to basically get the density plot in this histogram. How do we do that? So let me copy this, and let's say, let me rename this as H2. So this is now going to change to this plot, and now I want to introduce another argument known as the kernel density estimate. So I want to say kernel density estimate should be true, right? I want to see the density plot in this histogram. So that's basically what I want to do. So let's quickly run this. Shift enter. Okay, so here we go. So we can see that, right? Yep. So there we go. So you can see the density plot in this histogram plot. Right. Now what can we do with this? I think this should be good for the histogram plot. Now let's move to another type of graphics for quantitative variable known as boxplot. So I want to create a boxplot. Let me change this to Markdown. Markdown, yep. So shift enter. Now I want to create a boxplot. There's another important graphs, or let's say tool for getting a quantitative variable done. The boxplot basically gives us a pictorial view of the 5-number summary. So I want to start with that of the using the library from the pyplot or the function from the pyplot. So let me give a name to this, pb boxplot1. So I want to say from pyplot I want to get a box plot, and this time my x coordinates is, I want to extract that of sepal dot length. Then I think we are good to go. So let's run this, shift enter. So here we go. So this shows us the box plots of the sepal dot length or sepal length in a vertical form, and this basically contains the 5-number summary. Right, so we have the minimum value in here, which is around 4.5. This gives us the first quartile around 5.2. We have the median value around 5.8. Then we have also the third quartile, which is around 6.4. And we have the maximum value, right? At the same time, we can look at the shape of the distribution, which seems to be approximately left skewed, right? So that is it with the box plot. Another way we can do this, we can also get a box plot from the Seaborn package or library. So let's say box plot 2, we want to use the Seaborn library, SNS, and want to get a box plot here, box plot. So my x is going to be that of sepal.length, sepal.length, right? And my y, I need, sorry, do I even need y in this? No. Maybe if I want to get the levels, which I'll come to that, let's you just get a box plot for separator length. We'll later look at how to get the box plot of the separator length across the levels of the species. So let me use data to be f that, right? So let's run this, shift enter. So here we go. Now we can look at it. You can see that this gives us shows us the box plot with separator length in horizontal form, right? And we can see the 5-number summary in here, the minimum value, first quartile, median value. You can see the maximum, the third quartile and the maximum value as well. Now we want to get box plot of this variable across the levels of the species. So let's do that. Box plot of sepal length across the levels of the species. Right, so I'm going to paste what I copied and change this to box plot 3. Right, now I'm going to change this to box plot, but this time I want to add a y coordinate part, which is going to be species. Right, so this will give me the box plot of the sepal length across the levels of the species. Let's run this, shift enter. So here we go. So we can now see that of Setosa in dark blue, Vesicala in orange, and Virginica in red. And we can see that with Virginica we can see some extreme values, which seems to be an outlier, but it's not, because you have to be very careful when you're dealing with outliers. I've left that out of this tutorial because it is something that is subject to the discussion. Anytime you want to deal with outliers, you have to make sure that you examine your data very well. For example, I did this in our previous tutorial. Let me do it again. Assuming these are the scores of some student in a particular class, right? Let's assume this is supposed to be in what percentage, 100%. Let's assume in your data recording or entry, you have some value like 172. This is going to be an extreme value and it's going to be an outlier, right? because it is not consistent. An outlier is any observation that is not consistent with the rest of the data point. This value seems not to be consistent because if it's 100% and you're having 172, it's an extreme value, and this time it becomes an outlier because it's not consistent with what we have. Now, if for instance someone gets a score mark of 2, this is also another extreme value because if you look at this from 1 to 9, the center of this distribution is around 60 to 70. So if you are getting a value, someone is scoring 2, this is an extreme value, but this time it is not an outlier because it is still within 100%. Right, so that is why I'm saying that anytime it comes to outliers, you have to make sure that you examine your data very well before you ignore or remove them. Otherwise, you may end up um, removing very vital information from your data set. So let's go back to our um, exploratory data analysis. So boxplot of sepal length across the levels of the species. So the fact that we have some extreme values here does not necessarily mean that they are outliers, right? Okay, so now we can proceed to what else? So we are done with boxplot. Now let's look at scatterplot. So another important graphics for quantitative variable is scatterplot. So let's look at scatterplot. So let me change this to markdown. Right, and shift enter. Okay. So now I want to get that of scatterplot. So we can get a scatterplot by making use of the pyplot function or library. So let's say C scatterplot CP1. So from PLT, which is pyplot, I want to get scatterplot. Right, so I'm gonna say this time I want my x to be sepal dot length and my y to be that of petal dot, let's say, length. Okay, yep. Then okay, because this time I'm dealing with pyplot, let me use the f dot for my f dot. Let's get that. Yes. Then f dot for my final dot extract. We are extracting this variable. Right. So I think we should be good to go. So let's run this. Shift enter. So this gives us a scatter plot for between these two variables, and we can see that there seems to be some some sort of strong positive correlation between sepal length and petal length. Let's try and do this using the Seaborn library. So I'm gonna say S. Okay, let me click there. SP2 scatterplot 2. I want to use the Seaborn library. So scatter plot, right? And my X should be sepal dot length, and my Y is petal dot length, right? And data should be f dot, right? So let's run this. Shift enter. So there we go. So this is the same as that, right? But this gives us the labels as well. So I think we are good to go. Now this is just for 2. Can we get a scatter matrix where we can get the scatter plot for all the quantitative measurements? Let's try and do that. So let's try and get a scatter matrix. So let's do that with a pi. Yes, we can do that with pandas. Yes. So let's say we want to get a scatter matrix, right? So this time I'm gonna say from pandas I want to use plotting, right? I want to use get scatter underscore matrix, right? So and this time I want to make use of this new dataset ND, right? This is what we used to for the data processing, when we wanted to extract our new data set, we wanted to ignore that of the categorical variable, so we extracted this. We obtained this 4 features, and I think you can get this if you can go back and watch the Exploratory Data Analysis 1 data summarization. When I was trying to pre-process the data set, I created a new data set which I named ND, right? So that's basically what I want to use in here. It consists of only just the 4 features without the categorical type. So let me clear this and go back, clear this. So I want to use that ND, right, so that I can get a scatter plot for this measurement. So let's quickly run this and see. Shift enter. So it's taking some time. Once it's done, we will see a number and the output will show for us. Okay, so here we go. So we can see a scatter matrix here where we get a scatter plot for all the variables, right? And in here we can see some strong positive correlation between petal length and petal width, petal length and petal width, right? The same applies to sepal length and petal length, sepal length and petal width. There seems to be some strong positive correlation as well. And we can see the histogram plot on the diagonal. We can change this if we wish to. So let me copy this and paste it here. Sorry, paste. So I'm going to change this to 1, scatter matrix 1, and add some features to this. So let's say this time I want the diagonal to be, let's say, I want to get the kernel density estimate, right, instead of the histogram plot. And I want to give a color to this. So let's say this should be green. Right, so let's quickly run this. Okay, so shift enter. Alright, so we can see that now we have a density plot on the diagonal instead of histogram plot, and we can see the correlation between the variables as well, right? So there seems to be a strong positive correlation between petal length, petal width. The same applies to sepal length and petal length, sepal length and petal width. Maybe if you want to see the strength of the correlations, you can make use of the correlation coefficient function. So let's say I want to get a correlation coefficient, right? So let me say this should be core, right, of ND. So shift enter. Sorry for that. So let's see this. Okay, I think, okay, sorry, it should be this. So let's say correlation coefficient CC, right? So from my new data, I want to get a correlation coefficient. This should be, yep. So here we go. So you can see that there's a strong positive correlation between petal width and petal length and petal width, right? The same applies to that of strong correlation between sepal length and petal length, and sepal length and petal width. There seems to be a strong positive correlation, right? So I think we are good to go now. Let's jump into that of how to get so there should be 2 points. Let me scroll back. I want to now jump into graphs for qualitative variable. So let me go back, go back, go back, go back, go back, go back. Alright, so I want to distribute 2.2.2, right? Let me copy this. So let me copy this. Alright, let's scroll back. Alright, so now I want to do that of oh, copy this. Oh, copy the wrong thing. So this should be 2.2.2, right? Which is basically when I want to look at some data visualization. Data visualization for the qualitative variable, right? Yeah, we have only one. So let's change this to markdown. Right, so shift enter. So I want to start with the bar graph. Right. So I'm going to use the frequency distribution that we created in Exploratory Data Analysis 1. So we did this. Let's run this and see shift enter. So we computed the descriptive statistic for the qualitative variable and assigned the object to FD, right? So that's why we see versicolor, and the first column is made up of the species and the second column is made up of the frequency. So this is what I want to use for the bar graph. All right, so I'm going to say FD, that is my frequency distribution. I want to plot, and the kind of plot that I want is bar, right? Let me give a color to this to be, let's say, um, sign, right? And let's say, what do we need again? Let's say I want to, okay, I think it's okay. So box or bar graph, right? So let's try and run this, shift enter. So this gives us a bar graph of our qualitative variable, right? I think we are good to go. Now we can also do this by making use of the Seaborn library. We have a count plot in there that we can make use of. So let's say um, bar graph 2, I want to use the Seaborn. So SNS dot count plot, right? So this time my X should be species, right? And what do we need again? My data should be F dot, right? So let's run this, shift enter. So this also gives us a bar graph, right? From the count plot function, the Seaborn library, you can also get a bar graph. Now, one of the um, other or most frequent, not even frequent, the other um, graph that is sometimes used for data visualization for categorical variable is the pie chart. So let's look at that of the pie chart. So for pie chart, first of all, we have to create our own species or categorical data. So if you look at this, we have to create our own species data so that the computation becomes easier for us. So in order to do that, let me say I want to use a library. I want to import the numpy as np, right? This library is very important because it provides some multi-dimensional array objects and tools for working with the arrays. So that's the reason why I have to, basically, because I want to create an array where I can have my species and create an array for this. So I have to get use, or I have to import this library. It's very important for creating your own arrays. If you have not installed, you can use the pip install numpy, right? But if you already installed, you can just skip this and just load the library, right? Straight away. So once we load the library, we can create, I want to do everything together, we can create or recreate I want to recreate the, the species variable. So I'm gonna say species, the name for my and the levels of the species what I want to create now. First one is vesicle, or let me start with setosa. Setosa. Then I want to get out of vesicle, right? And the last one is virginica. The showing quotes, right? Then the next array that I want to create is the frequency, right? So I want to say setosa is basically 49, right? And that of vesicle is 50, and that of virginica is 49. So once I've recreated this um, variable, now I want to get, yeah, I want to plot per chart or per graph. So it's PP for per plot or per chart. So I'm going to say I'm going to use the plot, plt pi. The pi function is in the plot library. So my x should be the frequency. Yep. So FUK, right? And now I want to give a labels, right? So labels should be species, species, of course. So I think we should be good to go. So Shift Enter, which will run everything for us. So here we go with our pi plot or pi graph for this species variable. We have virginica in green, setosa in blue, and vesicle in orange. So this is basically how to do data visualization in Python using the Jupyter Notebook. This is the second phase of the exploratory data analysis. Please, if you found value in this video, don't forget to subscribe if you have not, and also turn on the notification bell to get more updates. Thank you for watching.